So this is the last piece of the WMO report on United in Science. We are basically looking at early warning systems. I have a whole course on so-called S2S predictions and applications, so sub-seasonal to seasonal. When you think about forecasts, you think about short term, which is 1 to 3 days, medium term, which is 3 to 10 days, and the so-called extended range, which goes from weeks 2 to 4, or sub-seasonal. And then you have El Nino type forecasts, which are for seasons and years. Early warning systems supporting adaptation and disaster risk reduction. This is from WMO UN Office for Disaster Risk Reduction. Somebody has complained or commented on my YouTube channel that I say a lot. Well, it happens when you talk, but I'm not going to worry about it too much. I'm not trained in media presentations, so you can hopefully enjoy the podcast despite the that I do. Key messages here: early warning systems save lives, reduce losses and damages, contribute to disaster risk reduction, and support climate change adaptation. Less than half of all countries in the world have reported the existence of multi-hazard early warning systems, which is good news, with coverage particularly low in Africa, least developed countries, and small island developing states. Ensuring everyone on Earth is protected by multi-hazard early warning systems will require collaboration across diverse actors and innovative financing solutions. So India, for example, has invested a lot in improving its forecast systems, and it is sharing the forecasts with neighboring countries, and even has set up training programs for neighboring countries to come and learn on how to use the forecasts and so on. The elements of a multi-hazard early warning system would look like this based on WMO Early Warning System for All report. So you have people, the centered system that you want, multi-hazard early warning systems, which have outside the partnerships that are required that we just mentioned, and it requires development of these systems and operations. So you have there we go with right? Risk, knowledge, and management is important. Observations and forecasting are very, very, very critical, and there is always a feedback between them. So development depends on knowledge of risk and management requirements, and observations and forecasting help it to improve those. And then you have warning, dissemination, and communication, which again feeds back with the observations and forecasting to improve the forecasts continuously and keep the development going. And of course, the last mile problems require preparedness to respond, so that even when warnings are issued, people should be taught how to use those, and vulnerability is greatly reduced when they are trained to respond to early warning. Especially women and their education and training helps a lot with the entire family. Okay, socioeconomic benefits of early warning systems are listed as this. Several studies demonstrate consistently high returns and provide a strong economic rationale for investments into multi-hazard early warning systems. Drawing on the findings presented by the Global Commission on Adaptation, the MHEW's average cost-benefit ratio of 9:1 is higher than any other adaptation measures considered in this study. Ahead of making new infrastructure resilient and improving dryland agriculture crop production, this implies that every dollar invested in early warning systems could result on average in US $9 in net economic profits. However, the full socioeconomic benefits of a multi-hazard early warning system are likely to be underestimated, as some benefits are difficult to monetize, such as potential lives saved. So health improvements, lives saved, forests saved, cultural values, monuments, saved, and so on, are externalities on which value cannot be put. Good news, countries reported having multi-hazard early warning systems by year from 2015 to 2021 has gone up. So this is from 47 in 2015 to a steady increase to 95 by 2021. All data is cumulative as of April 2022. That's the best knowledge they have. So systematic observations financing facility, a foundational element of the UN early warning system initiative. Okay, this recording got cut off, so I'm going to restart here. So we were looking at this UN program to try to develop this global basic observing network, as it's called. So the systematic observations financing facility is basically trying to remind us that early warnings can only be as good as the data underpinning them. In 2021, the Global Basic Observing Network GBON was established, committing all countries to generate and exchange basic weather and climate data. However, today less than 10% of these internationally agreed data are available from least developing countries and small island developing states. These critical data gaps hinder the provision of high quality climate services around the globe. So here is a map showing areas in dark red that are far from meeting the most important requirements of the GBON. Areas in light red are close to meeting the requirements. Areas in blue shades meet or exceed the requirements. Obviously, rich countries are doing well, and some countries like India or China is doing well as well. India has had issues with data gathering and sharing, but poor countries and small island states are not doing so well. Obviously, this has to improve. For this reason, WMO, the UN Development Program, and the UN Environment Program established the Systematic Observation Financing Facility, SOFF, as a UN multi-partner trust fund with the support of an initial group of funding partners. SOFF provides long-term technical and financial support to the countries with the largest capacity gaps to close their GBON data gap with a focus on LDCs and SIDS. This new mechanism contributes to achieving the adaptation and systematic observation goals of the Paris Agreement through improved climate and weather observations essential for effective climate services and early warnings. Early warnings are a lot of times just weather forecasts, which are initialization problems, which means data is needed to initialize the forecast, and the extended range and seasonal forecasts can be coupled or can be so extended range, which week 2 to 4, can be just uncoupled or atmospheric model only forecasts which still need initialization, but a lot of them are not now coupled forecasts which require ocean initialization, which requires heavy data as well in the ocean also. So all these forecast skills cannot be improved, and in fact it's quantified that the improvements in weather forecasts in the northern and southern hemispheres from the 1960s to now have come basically from improved weather forecast, weather observation systems. So same has to extend now to the so-called climate services, where the forecast horizon is being extended, and the type of information produced for agriculture, for water management, for energy management, for health management, for disaster risk reductions in everything, and also for transportation management, aviation and other things, are relying on these kind of observations to produce reliable skill. So all that fits into the so-called S2S project under the World Climate Research Program, which is the sub-seasonal to seasonal forecast. We have talked about it elsewhere, and you can look up podcasts on my website if you're interested in that. So the IPCC headline statements for early warning systems then goes like this. They go like this: despite progress, adaptation gaps exist between current levels of adaptation and levels needed to respond to impacts and reduce climate risks, which is said with high confidence by Working Group 2. The largest adaptation gaps exist among lower income population groups, this is also with high confidence. And remember here, lower income population groups are not just in poor countries, least developed countries or small island developing states. They are also in rich countries and they are poor. Adaptation does not prevent all losses and damages, even with effective adaptation and before reaching soft and hard limits. Okay, losses and damages are unequally distributed across systems, regions and sectors, and are not comprehensively addressed by current financial, governance and institutional arrangements, particularly in vulnerable developing countries, again from Working Group 2. There are a range of adaptation options such as disaster risk management, early warning systems, climate services and risk spreading and sharing that have broad applicability across sectors and provide greater benefits to other adaptation options when combined, again with high confidence from Working Group 2. So it's fairly clear that early warning systems are key. Investing in them has high return on investments, and they save lives, property, avoid disasters, they protect financial and economic interests and water resources, health, and so on. So there are many things that don't have market value, like improving people's health after flood by using early warning systems to mitigate health impacts, air quality impacts, and so on. So one has to just make these choices, and as I said, the key is to combine the timescales. Early warning systems are short-term, day-to-day management and adaptation, whereas the decision horizon timescales of 2030, 2050, net zero timescales, global warming 2 degrees C, 1.5 degree timescales are critical in terms of mitigation and adaptation, but these are some things that are happening right now, as seen with all the events that happened in 2022, the disastrous flood in Pakistan, and so on and so forth. Okay, let's leave it here.